If you see an EV stranded on the side of the highway today, the massive cutting-edge lithium-ion battery under the floorboards is probably perfectly
Yeah,
fine.
it's almost certainly not the main battery.
Right. Instead, that highly advanced machine was likely brought down by, well, the exact same 12-volt lead-acid battery technology that was invented back in the 1850s.
Which is pretty wild when you think about it.
It really is.
Hmm.
Anyway, welcome to the deep dive. Today we are taking a look at the hidden hurdles of the electric vehicle transition.
And the really fascinating mobile solutions that are rising to meet them.
Exactly. We've got a great stack of sources for today's dive. We are pulling from a master's thesis from the KTH Royal Institute of Technology by Pedro Montoya, focusing on mobile charging.
We also have a really insightful industry analysis from Torque News by Rob Enderloh.
Yeah, that one covers the whole multifamily housing charging crisis. Yeah. Plus, we're looking at a report from Recharged on EV roadside assistance in 2025 and a press release from Be Charged EV about some explosive growth in fleet charging.
It's a lot of ground to cover, but it all connects, you know?
Okay, let's unpack this. Because adopting an EV right now is, it's a bit like buying the latest, greatest smartphone, only to realize your apartment doesn't have any wall outlets.
Right.
And then when it breaks, the tow truck driver might accidentally brick the whole thing.
That's a painfully accurate analogy, honestly.
So whether you already drive an EV, or you're thinking of buying one, or just, watching the tech landscape evolve, this deep dive is going to completely reframe how you view the infrastructure of the future.
Absolutely. Because the hardware is kind of outpacing the ecosystem right now.
Yeah, let's start with that 12-volt battery paradox, because the myth versus the data here is crazy. I always just assumed EVs broke down because people pushed the range too far.
Right. The classic desert highway scenario where the car just slowly dies.
Exactly. But the Recharged article completely shatters that. First of all, EVs actually break down less often than gas cars.
Yeah, the stats are pretty clear. It's 3.8 breakdowns per 1,000 for EVs compared to 9.4 for gas cars. And out of those EV calls, genuinely running out of the main charge is like maybe 1 to 2%.
1 to 2%.
Yeah.
So the real villains are just mundane things. 50% of breakdowns are the 12-volt battery dying, and then the rest is mostly flat tires.
Yep, just the boring stuff.
But wait, if they aren't actually running out of main charge, why is EV roadside assistance treated as such a high-stakes, specialized service? Like, why does it even need a 12-volt battery if it has a massive power plant under the seats?
Well, it comes down to safety architecture. So EVs fail differently. That high voltage traction battery operates at, 400 to 800 volts.
Which is massive.
Right, and you do not want 800 volts running through the dashboard switch when you roll down your window.
Oh yeah, definitely not.
So they use the 12-volt system as an isolated sandbox for the normal electronics, but more importantly, it controls the physical safety switches.
The contactors.
Exactly. The high-voltage contactors. These are heavy-duty relays. If the car is off, or if you get in a crash, they spring open and completely sever the main battery from the car so no one gets electrocuted.
Okay, that makes sense.
But to close those switches and actually drive, the car needs a low-voltage power source. So if your 12-volt dies, the brain can't send the signal to close the contactors. The huge battery is full, but the car is completely bricked.
Oh wow, so you literally cannot shift into drive.
You can't do anything. And that leads to the towing issue you mentioned earlier.
Right, because the Recharge piece talks about how dragging an EV is a huge liability.
It is. Because EVs usually have permanent magnet motors. In a gas car, neutral disconnects the wheels from the engine.
But in an EV, the wheels are geared directly to the motors, right?
Exactly. So if a tow truck just drags the driven wheels on the ground, those magnets spin inside their copper coils. It turns the motor into a generator.
Pumping power back into a dead car.
Right. It creates back electromotive force or back EMF. And because the contactors are open, that massive current has nowhere to go. It just hits the inverters and can literally fry them.
You'd cause like 5-figure damage just dragging it down the street.
Easily. And there are physical risks too, like improper jacking. If a tow operator misses the reinforced spot by an inch and puts pressure on the battery casing,
They could puncture it.
yeah, and exposing lithium to oxygen is a massive fire risk.
So the practical takeaway for your next road trip is pretty clear. You have to demand an EV-savvy flatbed all wheels up.
Always.
Use your car's tow or transport mode. And I guess respect the boring stuff. Change that 12-volt battery early.
Treat it like preventative maintenance for sure.
Okay, so if range anxiety and dead batteries aren't the real roadblocks to EV adoption, what is? I mean, the answer isn't on a highway, it's right at home.
We are talking about the charging desert.
Exactly. Rob Enderle's article in Torque News lays this out perfectly. The whole EV paradigm is built for the suburban garage owner.
You pull in, plug into the wall, wake up full. It's easy.
But for the tens of millions of renters and apartments, it is a nightmare. Property managers look at retrofitting and they just balk.
And you can't blame them. It's huge capital expenses. You're trenching through concrete, laying conduit, upgrading main electrical panels.
It's like having a gigabit internet router for the building, but everyone is fighting to plug into a single Ethernet cable in the lobby.
That is exactly what it's like. And the National Renewable Energy Laboratory, NREL, they viewed this equitable infrastructure as the absolute linchpin of mass adoption.
Because if you can't charge at home, you aren't buying an EV.
Right. But there are clever tech solutions bridging this gap without digging up the whole parking lot.
Like the automated load management software, the ALM.
Yes, ALM is brilliant. Traditional chargers are dumb. They assume every car needs maximum power all night.
Which would instantly trip the building's main breaker.
Exactly. But with ALM, you can have, say, 10 cars sharing a single circuit. The software distributes the load intelligently.
Wait, how does it decide who gets the power?
Telemetry. It looks at the cars. If car A is at 80% and leaves at 7 a.m., and car B is at 10% and leaves at 5 a.m., the algorithm writes the power to car B first.
Oh, wow. So it balances the load overnight? That's so smart.
It basically uses time as a resource instead of raw power.
And Enderle also talked about people who only have street parking. He mentioned European-style pole-mounted chargers.
It's leveraging existing street lamps. It's a huge opportunity.
But I was wondering, how does a street lamp have enough juice to charge a car? Aren't they just running, like, LED bulbs?
Now they are, yeah. But decades ago, they were wired for massive, power-hungry sodium lamps.
Oh, so when they swapped to LEDs, they left all this extra capacity in the lines.
Exactly. The underground wires can handle way more load. Plus, streetlights draw power at night, which is exactly when people park and charge.
You just bolt a charger to the pole. No trenching required.
Exactly.
Okay, so if landlords won't build chargers fast enough and city permitting takes months, how do we fix the charging desert and keep commercial fleets moving right now?
Well, we stop bringing the car to the charger.
And bring the charger to the car. This brings us to Pedro Montoya's thesis from KTH on mobile charging as a service, or MCASE.
It's a totally different way of thinking about the grid.
He's talking about off-grid, modular battery packs with predictive algorithms. But when I first read this, I was skeptical. Are we really going to drive heavy batteries around in diesel truck to charge green cars?
It sounds counterintuitive, I know. But Montoya's architecture relies on optimization. These units aren't just driving around aimlessly.
Right, they use data to pre-position the hubs.
Exactly. They look at fleet routes, historical demand, even weather. They charge the mobile units at a central depot overnight when grid power is cheap and renewable.
Then they deploy them locally. And we are seeing this scale up in the real world right now. Look at the B-Charged EV press release.
Yeah, that's a perfect real-world application.
They power 250 fleet vehicles in just 60 days across 15 states. They do that 247 roadside assistance we talked about, adding like 15 to 40 miles to stranded drivers.
Which totally bypasses that whole towing nightmare.
Exactly. But their real breakthrough is simultaneous multi-vehicle charging for entire commercial fleets.
Because fleet operators are desperate for EVs. The CEO of B-Charged, Antonio Curabito, noted that 87% of fleets want to transition in 5 years.
But the infrastructure is the barrier. You can't wait 2 years for a utility permit.
Right. So a mobile charger just rolls into the yard at night, charges all the delivery vans, and leaves. It scales dynamically with the business.
So here's where it gets really interesting to me. Is this mobile charging just a temporary Band-Aid until we pour enough concrete? Or is it a permanent shift?
I think it's pointing toward a permanent evolution, especially when you look at what Torque News mentioned about autonomous charging robots.
Oh, the battery packs on wheels.
Yeah.
Basically giant Roombas that charge your car.
Exactly. Automakers are developing these right now. Imagine living in an apartment. You just park anywhere in the garage. While you sleep, a robot navigates over, slides under your car, and charges it totally wirelessly.
Sounds like sci-fi. But wait, isn't wireless charging super inefficient? Like you lose a ton of energy as heat.
Traditional wireless, sure.
There.
But these use magnetic resonance coupling.
Okay, what does that mean?
It means the robot and the car's receiver are tuned to the exact same electromagnetic frequency. They can transfer power across a gap of several inches with, like, 90 to 93% efficiency.
That's almost as good as the physical cable.
Yeah, it's incredible.
It is wild. But what's funny is looking at the KTH thesis, there's a deep historical irony here. We've actually been trying to solve this for over a century.
Oh, the early 1900s EV boom.
Yeah. Back then, like 38% of U.S. cars were electric. And because there were no chargers, they just physically removed the heavy lead-acid batteries, carried them to a charging room, and swapped them.
And by 1914, GM had that DC charger, the Electrant, that looked like a phone booth.
Right. Standardizing connectors has literally been a 100-year headache for us.
It really has. But to fix it permanently today, we need a structural shift.
Which brings us to the policy horizon. Enderlo outlines what actually needs to happen. Automakers have to stop acting like just car sellers.
Right. They need to be ecosystem providers, like how tech companies operate.
He suggests they should be subsidizing property managers or bundling the cost of a smart charger into the car lease itself.
Because relying on landlords to just volunteer their capital isn't working.
Exactly. And that's where the sweeping right-to-charge legislation comes in.
That's a huge piece of the puzzle. Right now, HOAs can just say no to a charger because it's annoying to deal with.
But right-to-charge laws shift the burden. It makes it a legally protected process for a renter to install a charger if they pay for it.
Right. And for the heavy grid costs, the trenching and the transformers under law points to utility make-ready programs.
Oh yeah. Explain how the front of the meter versus behind the meter works.
So the utility pays for everything on the front of the meter. They dig the trenches, lay the conduit, upgrade the transformer.
Which is the super expensive part.
Exactly. And the property owner just pays for what's behind the meter, which is basically just the charging pedestal itself.
But why would a utility company pay for all that trenching?
Because they want to sell electricity at night. Managed EV charging provides a massive, stable demand during off-peak hours. It balances their whole power grid.
It's a win-win. Enderle forecasts that we are just in the messy middle period right now. Permitting is slow, landlords are hesitant.
But he thinks by 2032 or 2035, the charging desert will largely evaporate.
Because by then, battery densities will standardize around 400 miles of range.
Right. And if you have 400 miles of range, you don't need to charge every single night.
Oh, that makes sense. You might only need that autonomous charging robot to visit your spot once every couple of weeks.
Exactly. It changes the whole demand equation.
Wow. Okay, so to summarize the journey we've been on today, we started with the surprising reality that it's usually just a tiny 12-volt battery failure that strands EVs and forces these risky, specialized tow jobs.
Right, not the massive high-voltage pack.
From there, we dug into the incredibly frustrating multifamily charging deserts and saw how automated load management and retrofitted street lamps are kind of hacking the existing infrastructure.
Hacking it with software instead of concrete.
Exactly. And finally, we explored the rise of MKS modular mobile charging fleets and autonomous robots that bring the energy directly to the car.
It's all about making the grid flexible.
So next time you see an EV silently gliding down the street or parked outside an apartment, realize you're looking at a vehicle at the absolute center of a massive infrastructure tug-of-war.
A tug-of-war that is redefining urban living.
Totally. It is reshaping the physical architecture of our power grid.
You know, it leaves us with a really fascinating scenario to think about.
What's that?
If these mobile chargers and autonomous battery robots and highly efficient modular systems become the new normal, will those permanent concrete gas station-style charging plazas become obsolete before they are even fully built out across the country?
Oh, wow.
Like, could our vehicles soon essentially act as mobile power plants that independently order their own energy deliveries while we sleep?
Completely untethered from a fixed wall outlet. That is a wild thought to end on. Are we building the wrong permanent infrastructure?
It's definitely something to consider.
Well, you have plenty to mull over now. Thank you so much for joining us on this deep dive. Keep watching the grid around you, and we'll catch you next time.